So in trigonometry, we're gonna have to use limits. So there's just two properties that we have to know, and they're actually pretty easy to remember. So this is how I remember them. Well, the first one is that as the x approaches infinity, sine x over x, it goes to 0, and 0 sine x over x goes to 1. So one thing you have to know is that these guys are basically the same. So it's sine x over x. Okay, so that's one last thing we have to remember. And how do I remember what these? This is basically the only thing you have to remember. Now, how do I remember these? Well, this is how I remember it. I just remember negative infinity is the first one, and that goes to 0. And then 0 goes to 1. So what do you notice about this pattern? It's in like descending order, right? Because negative infinity is the smallest, and then 0 is bigger and 1 is bigger. So you know that the limits will look like this. It goes like negative infinity to 0 and 0 to 1, as you see right here. And of course, when you think of negative infinity, you can always just add a plus sign. But I put it as negative infinity so I can remember. So these are two like trig identities we have to know. So now let's look at some applications of these identities. I'm going to give you some practice problems. So let's see, I'm going to use this guy first. So we see that this doesn't exactly match up with this identity. So how can we manipulate this expression so that it will match up? So we see it's sine 2x over x, and we need it to be 2x on the bottom as well, because if we have the same this guy, if this guy is the same, then we can just set it equal to 1. So what I'm going to do is I'm just going to add what I need. So what do I need in this case? I need a 2. And in order to balance it out, I'm going to put a 2 over here as well. So it becomes like 2 over 1. So basically, I'm just multiplying by 2 over 2, right? And 2 over 2 is just 1. So if you multiply by 1, it doesn't change the overall fraction. So what does this sine 2x over 2x give me? I can just rewrite sine, this is basically just equal to 1, because of our identity that says sine x over x is equal to 1. And when it says x, it means any value is just as long as this guy and this guy are the same. So 2x and 2x, this guy, overall guy, is just going to become 1. So let's rewrite that. This is just going to become 1. So it's just 1 times 2. So our limit is going to be 2. It's pretty good, right? Okay, let's do some more. So before we do this problem, the one thing I want to tell you guys is that the second identity, the reciprocal of it also works. So the reciprocal just looks like this. Instead of sine x over x, it's x over sine x. So both the reciprocal will work. This one is not, it won't work for this one. It just works for the second identity, that if you do the limit as x approaches 0, the reciprocal of this identity will also work. So you can just think in your head, you know, the one with 0 and 1, the one that's more to the right in terms of negative infinity, 0 and 1. You can think about this guy. This guy will have the reciprocal working for it as well. So let's take a look at how we can use this one, because we'll need it here. So what we're going to do is we're going to add an x here, and that will allow us to cancel out sine 4x and 4x. So if we added x on the numerator, we have to add an x in the denominator. So I added 1 over x. So basically we're multiplying both sides by x times x, x over x. So after we do that, we see that we can basically just cancel it out, because it's really just multiplying by 1, and multiplying by 1 doesn't change it. So after we did that, we have a sine 5x over 1, because this side is 1, times 1 over x. And we can just rewrite this as like this. We can just write it like that. So now how do we make this how we want? We're going to add another 5 here. But if we add a 5 on the bottom, we have to add a 5 on the top. So then what does this become? This just becomes 1. 1. And 1 times 5 is just 5. So our limit is 5.